Hello and welcome to this YouTube channel. In this video, would be giving answers to the October-November IGCSE chemistry. All right, so let's dive in straight to the questions. Okay, so we have the first question here. We're given a list of chemical and physical processes, and you're expected, of course, to use these processes to answer the following questions. All right. So the first question says, which of these processes happens when an acid reacts with an alkali? So when you see an acid plus an alkali, you should know that you are going to form salt plus water, and that is simply a neutralization reaction, right? So that means our answer is simply D. The next one says, which of these processes reaches a position of equilibrium? Now, when you talk about equilibrium, then you're talking about a reversible reaction. All right. So the answer is F, of course. So we just are filling F here. Which of them involves particles changing from fixed positions to being mobile but still touching? Now, for particles to be in fixed positions, they're likely solids. So solid particles are always in fixed positions, vibrating about a fixed position. Okay. Now, for them to move to being mobile but still touching, then you're likely moving to a liquid. So, in other words, this question is saying which process involves changing from a solid to a liquid. So, look at the options. We have melting. So, melting is the process that simply changes a process whereby the solid changes to the liquid. All right. So we go to the next one. Which of these processes are physical changes? Now, remember that physical changes are changes that are reversible. So the physical changes are those changes that are reversible. So if you look at all the options we have, we see that thermal decomposition, no, it's not a physical change. This is not a physical change. Okay, this is a reaction. All right, this is not a physical change. So you can look at others, you see that diffusion, yes, is a physical change. Melting is a physical change. So we just fill that B and C. And then the last one says, which of these processes is caused by gas particles colliding with each other? Now, for gas particles to collide with each other, meaning that it means that these particles are moving from a higher concentration to a lower concentration, and diffusion fits into that description. So diffusion is B. Okay, so and that answers all of that all of those questions there, which is quite easy. All right, so we go to the next one. The question is about atomic structure and the periodic table. So define the term nucleon number. Now, nucleon number also means mass number, right? And you can recall that mass number is the number of protons plus the number of neutrons. So the nucleon number, this is the total. This is the total number. This is the total number of protons and neutrons in the nucleus, because the protons and neutrons are in the nucleus. So the total number of protons and neutrons in the nucleus of an atom. That is what we refer to as the nucleon number, or we refer to it as the mass number. State the connection rather between the number of occupied electron shells in an atom and the period number of that element. So let's take, for example, sodium 11, proton number 11, mass number 23. So we want to write a configuration of sodium 11. We're going to have first shell, 2 electrons, second shell, 8 electrons, and to complete it, we have 1 electron. All right, so the number of occupied electron shells in sodium, in this case, is 3. All right, and then the period of sodium as an element is also 3, meaning that the number of occupied electron shells and the period number of an element are the same. So we simply say they are the same. That is the connection. They are the same. Right. Write the electronic configuration of the following atom and ion. Okay, silicon 14, so first shell 2, second shell 8, third shell 4 to balance the 14. And then for the next one, the chloride ion. So chloride ion, it's chlorine 17, but it has a charge, a negative charge, meaning it has gained an electron. So the number of electrons in that ion becomes 17 plus 1, okay? Because it's gaining an electron. That's a negative 1. So there are 18 electrons in the chloride ion. So we're going to write the electronic configuration based on this now. So it's going to be 2, 8, right, and 8. So that is how to solve that question. They're quite easy questions. Okay, so we go to the next one. We asked to complete number of neutrons and electrons, still on atomic structure. So the number of protons, since this is a neutral element, what do we mean by a neutral? A neutral element is an element that is not charged. So an element that is not charged is referred to as a neutral element. So this is neutral. And since it is neutral, the number of protons is equal to the number of electrons in a neutral atom or a neutral element. So since the number of protons is 11 here, the number of electrons should equally be 11, since it's neutral, it's not charged. To get the number of neutrons, remember that nucleon number or the mass number is equivalent to the number of protons plus neutrons. So since we need n, so n will be equivalent to mass number minus the proton number. So the mass number in this case is 23. So we're going to have 23 minus 11, and that is 12. So our answer here is 12. For this ion, the number of protons is 9. It is charged. This is charged. This is not neutral. It's charged. Therefore, just like we said, it's negatively charged, meaning it has gained an electron. So the number of electrons here will be the proton number plus the electron that was gained. All right, so that's 10. All right, so it's 10. Since there's a negative 1, so we just add that negative 1, the electron that was gained rather, to the proton number. And then the next question here, we're given the number of protons. We check your periodic table. You see this is gallium. Gallium has proton number 31. All right, so since we know that, the next thing is look at the number of electrons. It's not the same as the number of protons, meaning that this gallium is not a neutral one. It's charged. And it is not just charged, it is positively charged because the number of protons is more than the number of electrons. It is positively charged. So difference between 31 minus 28, that's the difference of 3, meaning it's a 3 plus. Okay, meaning it is giving out 3 electrons. All right, and then to get the mass number or the nuclear number, just like we have it, protons plus neutron. So we just have 31 plus 38, and that should give us 69. All right, and that solves this question. All right, as you can see, this it's quite easy. All right, next question. A sample of thallium contains 2 isotopes. So we're given 2 mass numbers of thallium, meaning they are isotopes, and also means that they have the same number of protons. So the same number of protons, different number of neutrons. That is why they are called isotopes. Same number of protons, different number of neutrons. So we're asked to define the term isotopes. So isotopes are atoms of the same element. Isotopes are atoms of the same element. But the fact that we mention atoms of the same element means they have the same proton number with different number of neutrons. Different number of neutrons. Remember, because they have different number of neutrons, you could see their mass numbers are affected. Okay, because of the different number of neutrons, their mass numbers are affected. So they have different mass numbers. So they should have the same number of protons but different number of neutrons. Now, atoms of the same element caters for the point where you mentioned they have the same number of protons. All right, so we go to the next question, talking about calculating relative atomic mass. And you're given the 2 isotopes, you're given their ratios. So the first thing you should do here is to get the total ratio. Total ratio is 3 plus 7. That is 10. Total ratio is 10. Therefore, relative atomic mass, I'll just call it RAM in this case, will be the percentage, the abundance of the first isotope, 3 over the total abundance, 10 times the mass of the first isotope, 203, plus abundance of the second isotope, 7, all over the total abundance or the total ratio, 10 times the mass of the second isotope, 205. So this is what you're expected to do. So now we're going to compute using a calculator as usual. So I'm just going to use my calculator here, and I would have so I have 3 times 203 divided by 10. So I'm having 60.9. So RAM here is 60.9 plus. I do this for the second one again, 7 times 205 divided by 10. So I'm having 143.5. So I'm going to add this up. 143.5 plus 60.9. So 204. So 204.4. Our answer is 204.4. That's the relative atomic mass of the element itself. Next question says, suggest why these two isotopes have identical chemical properties. Now, the identical chemical properties is based on the fact that they have the same number of protons, meaning that they have the same electronic configuration. They have the same electronic configuration. Okay, they have the same electronic configuration, meaning they are the same elements, the atoms of the same element, so they should have the same electronic configuration, and that would translate to them having identical chemical properties because they would have the same number of electrons in the outer shell, right? So that's the point to prove for that. So it's quite easy, like I said. All right, so we'll go to the third question. You're given copper sulfate formula. Copper 2 sulfate, you told that its aqueous form is in a blue solution. The sample of copper 2 sulfate, aqueous copper 2 sulfate is made by adding excess of a copper 2 oxide to hot dilute sulfuric acid. So complete the symbol equation for this reaction and include the state symbols. All right, so we have copper 2 oxide plus sulfuric acid. We have copper, this is simply a basic oxide plus an acid. So basic oxide is a basic oxide plus an acid, right? So since you should have salt and water, right? So that's just it. Now, state symbols. Copper 2 oxide, you were told that it's added in excess, meaning it's in the solid state. We were told that the the sulfuric acid is in dilute form, so it's an aqueous state. And then you were able to produce aqueous copper 2 sulfate. It's already stated here, so you should know this is equally aqueous. State one observation which shows that copper 2 oxide is added in excess. Now, there are two indicators to tell you that a substance is added in excess. Number one is the fact that effervescence stops. But in this case, we are not producing a gas. So that point doesn't fit into this description. So we cannot say that effervescence stops here because no gas is produced in this reaction. So we have to go to use the second one, which says that you would have the presence of undissolved copper 2 oxide to show that is in excess. So we simply use that. So presence of undissolved solid. So the solid presence of undissolved solids represent copper 2 oxide. Describe how aqueous copper 2 sulfates can be separated from the reaction mixture. Now, after you have added in excess, of course, the next step is to separate it. All you need to do is to filter. So filtration. So filtration is done to remove the excess of a copper 2 oxide before you now take the next steps. Right. Crystals of hydrated copper 2 sulfate can be obtained from aqueous copper 2 sulfate by crystallization. All right, and then you ask to state the term, what is meant by the term hydrated. So a hydrated substance, or the term hydrated means a substance. This is a substance. This is a substance that is chemically bonded or chemically combined with water. This is substance chemically bonded to water. So you call it hydrated because it's chemically bonded. So write the formula of hydrated copper 2 sulfate. So this is copper 2 sulfate. For it to be in the hydrated form, you're going to have the dots there and then you have the 5H2O. So this is how copper 2 sulfate is represented in the hydrated form. Describe how this crystallization is done. Now, simple, after you filter, remember, you have your filtrate. So the next thing is to heat the filtrate, heat to point of crystallization, heat to point of crystallization. Don't just write heat. Okay, you have to tell us that you are heating it to a point of crystallization and leave to cool. So by the time you leave it to cool, the crystals will form in larger quantity. So it's to point of crystallization and leave to cool. That is how the crystallization is done. Then you should also add wash with distilled water, okay, and leave to cool. Then wash with distilled water, and then you leave to dry. So these are the steps you could follow for the crystallization process. Okay, so I think we're done with that part. So let's go to the next question. Aqueous copper 2 sulfate undergoes electrolysis using graphite electrodes. State why aqueous copper 2 sulfate conducts electricity. Now, you need to be careful here. This is an ionic compound. And remember the reason why ionic compounds conduct electricity. They have mobile ions. Remember, ionic compounds contain ions. So their ions are mobile. They contain mobile ions. That is why they conduct electricity. Give two reasons why the electrodes are made of graphite. Now, there are two things that qualifies a substance to be used as an electrode. Number one, it has to be inert. Inert means it has to be unreactive. And then secondly, it has to be a good conductor of electricity. A good conductor of electricity. So that is why graphite fits into being used as an electrode. Describe how the appearance of the electrolyte changes during the electrolysis of aqueous copper 2 sulfate. So in this case, we're just going to write out the ions involved in this process. So we're going to have copper 2 plus, we're going to have sulfate ion, we're going to have hydrogen ion, and then we're going to have hydroxide ion. Okay, since it's in aqueous form, okay, and remember that the aqueous copper 2 sulfate is blue in color. Okay, it's blue in color. So these are the ions. Now, cathode, these two positive ions are competing for the cathode. That's copper 2 plus and hydrogen ion. And then these two other ions are competing for the anode. Let me just title it the anode. So between these two, remember the condition is that the less reactive one will be deposited at the cathode. All right. And also remember that the blue color in the copper 2 sulfate is solely because of the presence of copper 2. So this is what is responsible for the blue color. Now, between these two, since copper is less reactive than hydrogen, it goes to the cathode, meaning that as the copper 2 plus ions are deposited at the cathode, the blue color fades. So the solution fades. That means the solution begins to lose uh, it begins to lose its blue color. So that is what is happening there. The copper 2 plus ion is moving to the cathode since it's less reactive. Therefore, the blue color begins to fade. So the solution will fade. Okay. Describe what is seen at the cathode during the electrolysis of copper 2 sulfate. Okay, so since copper is being deposited, you're going to have a brown or pink deposit. So you're going to have pink or sometimes say brown deposit. So pink deposits observed, pink deposits observed. Or we say pink solids, or we say pink solid observed, pink solid. Okay, so you're going to have pink solid at the cathode. Hydroxide ion moves. Remember, condition, since it's aqueous, Aqueous copper 2 sulfate means there are more of this present, so this would be deposited at the anode. Now remember, from your knowledge of electrolysis, when the hydroxide ion moves to the anode, you're going to have OH minus, losing electrons to produce oxygen gas, plus water, plus the electron that was lost. And most time we balance it by putting a 4 here and putting a 2 right here. So this is the half ionic equation taking place at the anode. All right. Now, state two differences seen if the electrolysis is repeated using copper electrodes instead of graphite electrodes. All right. Now, if you switch the electrodes from graphite to copper, let's go back to our equation, our this breakdown. So it means that as copper ion is being deposited at the cathode, some copper ions at the copper would also move into the solution. So it's more like as copper ions is being deposited at the cathode which is made up of copper would also move some ions back into the solution. So what you would observe in such case is that the color would not fade. Remember, as copper is being deposited, copper from the electrode is moving back into the solution. So the color will remain the same, color remains the same. So I'm going to have the blue color, color remains the same. That's one of the observations you would see, color remains the same. That's one of the observations. And one of the differences you would observe when you switch the electrodes.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable and you get the very best of service. We also have for the E-levels as well, and also for the EdExcel. So we have for the Cambridge E-levels and EdExcel E-levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E-level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E-level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Ajiro Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE and then for the E-levels. Again, for the IGCSEs, these are the subjects, and for the E-levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team If you're an IGCSE student preparing for IGCSE, if you're watching this in 2024, 5, watch this in 2026, watch this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore and then get it tailored to your own needs. So trust me, you don't want to miss out.
Yeah, a second difference you would also observe is that in the case of graphite, remember that the hydroxide ion will produce oxygen gas, and since graphite is made up of carbon, it will react with the oxygen to give carbon dioxide gas. So in the case of using graphite, so there will be no bubbles at the anode because no gas now will be produced at the anode. In the case of graphite, when you're using graphite, just like I outlined here, the graphite will react with the oxygen gas produced at the anode to produce bubbles of carbon dioxide. But now that you've changed to copper, there will be no bubbles at the anode. So you're not going to observe any bubbles at the anode. All right, moving to the next one. Okay, question 4 this time. You have the equation for the reaction, and you have to state the change in oxidation number of nitrogen in this reaction. So let's pick it up. Magnesium is in group 2, so it has a charge of +2 plus, okay, so this 2 is affected, nitrogen is affected by the 2, so it becomes plus 2n plus, oxygen is -2, but it has 2 and 3 here, so 2 times 3, that's 6, so oxygen is going to be 6 into brackets -2. Everything should be equal to 0. So in this case, it becomes plus 2 plus 2n minus 12 equals to 0. So 2n will be equal to 12 minus 2. 2n will be equal to plus 10. Then divide by 2. So n will be plus 5. So I'd have plus 5 here. All right, so that's where nitrogen is. So let's go to where nitrogen is in the product. So remember in NO2 now, in case of NO2, you know that oxygen is always -2. So you're going to have n plus 2 into bracket -2 equals to 0. So n minus 4 equals to 0. So n in this case is plus 4. So from moving from plus 5 to plus 4. Identify the element which is oxidized in this reaction. So we've seen that nitrogen is reduced because there's a reduction in the oxidation number of nitrogen. So definitely it is not nitrogen. So let's look at magnesium. Magnesium in this case is +2 and is equally +2 here. Okay, so magnesium is not changing. Oxygen is -2 here. It is -2 here. It is equally -2 here. But when you get here, it's 0. So 0. Oxidation number is 0. So that means oxygen is being reduced here. So we'll just write oxygen. All right, and that solves that. Okay, so move to the next one. Calculate the volume of NO2 gas as RTP formed when 7.40 gram of magnesium nitrate is heated. So the first thing is to calculate the relative molecular mass of this compound. So we know that magnesium is 24 plus nitrogen is 14, so 2 times 14 plus oxygen is 16, so 3 times 2, that's 6 times 16. So let's sum this up. Let's simply use my calculator here. So we're going to have 24 plus 28 plus 16 times 6, that's 96. So 96 plus 28 plus 24, right? I have 148. So 148. All right, calculate the number of moles of magnesium nitrate used. So we have the mass and we have the molar mass. So number of moles is mass over the relative MR. So we're going to have N equals to 7.40 divided by 148. So let's compute that. By the time you compute that, you're going to have 0.05. Yeah, that's on the calculator. So 0.05 moles. Mole, correct. Now, we have the number of moles of the compound. So next thing is determine the uh, number of moles of the oxide of nitrogen. All right. So to determine the number of moles of the oxide of nitrogen, we have to go back to the reaction, equation of the reaction, because we do not have so much information about the oxide of nitrogen, but we have a known, which is number of moles of magnesium nitrate. So go back to the equation of the reaction. Look at the equation of the reaction. You see that the compound, look at nitrates, the nitrate compound compared to the oxide of nitrogen. Let's look at the ratio. So we see that this to this now is so I'm just going to write it here now. So you see what I'm saying? This is magnesium nitrate ratio oxide of nitrogen. Okay. So what we have there is let's go and see the ratio 2:4. So its coefficient here is 2, the coefficient here is 4. So that is the method you use to solve this 2:4. Since we do not have a lot of information about this, now since we know that, then we already obtained number of moles from here. So what would 0.05 give? So this will give x. All right, so you could solve for x here. Okay, so that's 2x equals to, that's cross multiplying here, and then you have 0.05 times 4. So 0.05 times 4. So divide by 2, divided by 2. Let's compute that 0.05 times 4 divided by 2. So what I have here is 0.1. So 0.1. And you can see, you could use this strategy when you are not given so much information about the compound you asked to find the number of moles. So just use stoichiometry. Compare the ratios of the known with the unknown, and then from there you can obtain the number of moles. All right, now calculate the volume of this the oxide of nitrogen gas in cm cube. You have to be careful here. It says in cm cube. So since this is a gas, remember the formula for gases, number of moles is volume divided by 24 dm cube. So we need to convert dm cube to cm cube. So 1000 cm cube is equivalent to 1 dm cube, meaning that our formula can become V all over 24,000 cm cube. So we're looking for V. So V will be equivalent to what's the number of moles of the gas? 0.1 times 24,000. So by the time you do your multiplication, you should have 2,400 centimeter cube, and that gets you the answer. All right, bonding, ionic compound. Okay, you already told it's an ionic compound, meaning there's going to be a transfer of electrons. So first thing you should do in questions like this is to write the configuration of each of the elements involved. So I'll start with magnesium. Magnesium is 12, so the configuration is 282. And then for oxygen, which is 8, the configuration is 26. All right, now the next thing is I'm going to write, going to draw. So it says complete the dot and cross diagram of the ions. These are ions, meaning that magnesium must have given out these two to oxygen, which must have received the 2 electrons given by magnesium. So meaning I have to draw another circle and ignore these 2 and just draw these 8. So 1, 2, 3, 4, 5, 6, 7, 8. And I know that magnesium should give out 2, so it's going to be 2 plus. And then I'll draw that of oxygen, right? 6. So 1, 2, 3, 4, 5, 6. And then the 2 electrons received from magnesium. So one is received in this available space here, and the other is received here. So oxygen becomes 2 minus because it has received 2 electrons. And that solves that question. Oxygen is a covalent molecule. Complete the dot and cross diagram in figure 4.2 of a molecule of oxygen. So this is a covalent compound in this case. Remember, oxygen is 8, so we have 2, 6. And we have 2 of them. So you have been, this one has been drawn for you already. So you have to complete the 6. So I'll complete the 6 here. 1, 2, 3, 4, 5, 6. And I'll do the same thing for the other end. 1, 2, 3, 4, 5, 6. Now, when you do something like this, This should tell you that you are wrong, because no electron after bonding should be left unpaired. So you could see that these two electrons here, one here and this, are left unpaired. So when you have something like this, all you need to do is to move this one and this into the intersection. So I'm going to erase this now and do the right thing. So I'm going to erase this. I'll move both of them into the intersection to join these ones that are here already. So see what it's going to look like. So it's going to look like this was initially there, then I move this and this. So this is what you're expected to do. Okay, so it's always good to use a pencil to first draw this, so that when you see that some electrons are unpaired, you now move them into the intersection, because no electron after bonding should be left unpaired. All right, moving to the next one, question 5. Hydrogen is the first element of the periodic table. Hydrogen is used in fuel cells to produce electricity in vehicles. Name the substance which combines with hydrogen in fuel cell. Now you already know that the equation for hydrogen oxygen fuel cell is hydrogen gas plus oxygen gas to give water, right? So this is oxygen, right? So oxygen. Give one advantage and one disadvantage of using fuel cells instead of gasoline in vehicle engines. Now, in one of the advantage of using the hydrogen fuel cell instead of gasoline. Remember, gasoline has to do with burning of hydrocarbons. And one problem with burning of hydrocarbons is that you have to produce complete combustion of the hydrocarbon to give carbon dioxide, which becomes a greenhouse gas. So one advantage of this hydrogen oxygen fuel cell, look at the product of the hydrogen oxygen fuel cell. It doesn't produce carbon dioxide. So that's one advantage. No carbon dioxide produced. No carbon dioxide produced. Now, disadvantage of this hydrogen oxygen fuel cell is that it is expensive. Okay, it's expensive. All right, or you could simply say hydrogen is hard to store. So we need hydrogen as a gas is hard to store. So you either use this expensive, an expensive process, or you simply say hydrogen is hard to store. It's hard to store. All right, and another disadvantage is the fact that there are very few hydrogen filling stations. Okay, so we do not have hydrogen filling stations, very few of them. So either of them can be fixed into these disadvantages. It's expensive, hydrogen is hard to store. There are very few hydrogen filling stations.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable and you get the very best of service. We also have for the E-levels as well, and also for the EdExcel. So we have for the Cambridge E-levels and EdExcel E-levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E-level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E-level. So all you have to do, if you're watching this right now and you are interested for um, a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at agile@gmail.com, and they'll reply to you. And the good news about this is what I've discussed with the sales team is we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, um, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So, again, what are you waiting for? Just send an email to the system. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
All right, hydrogen gas can be made from petroleum by a two-step procedure. Petroleum is separated into different components. Large molecules obtained in step one are converted into smaller molecules, including nitrogen gas. Name the process used in step one. Of course, if you want to separate petroleum into different components, you should know that fractional distillation is the process used. Fractional distillation. And then for step two, you were told that large molecules are converted into small molecules, including nitrogen gas. That is simply cracking. That is cracking, because cracking is the breakdown of large hydrocarbons, majorly alkanes, into smaller hydrocarbons, useful hydrocarbons precisely. All right, so we have a question here. Organic compounds contain hydrogen atoms. Calculate the number of hydrogen atoms in 44 grams of the ester methyl propanoate. Given the formula of the methyl propanoate, and you were told that 1 mole of the methyl propanoate contains Avogadro's constant, which is 6.02 times 10 to the power 23, and also to put your answer in the standard form. So first thing we would do is we want to get the number of moles of methyl propanoate. We have to get the number of moles of this compound first before we can calculate the number of hydrogen. Okay, let's just write formulas we need. So to get the number of hydrogen atoms, remember the formula. Number of moles equals to number of atoms all over 6.02 times 10 raised to power 23. This is a formula that helps us calculate the number of atoms. So since we are looking for the number of atoms, we need to get the number of moles of the hydrogen atoms, and then we multiply by this. So for us to get the number of hydrogen atoms, first we need to get the number of moles of the compound itself, which is the ester. So how do we get the number of moles of the compound? Remember, number of moles is mass over molar mass. So we need the molecular mass of the ester. So the ester is, so we're going to calculate that. So carbon is 12. So 12 plus 1 times 3. Let's draw this line here. Plus another 12 plus 1 times 2. Okay, plus another 12. Oxygen is 16 plus 16 again, plus 12 plus 1 times 3. Right, I think if we compute this, we should have 88. Right, 88 is the relative molecular mass. So since we know the relative molecular mass, then number of moles now will be easier. Number of moles will become the mass, 44 divided by 88. So number of moles here is now 0.5 moles. So this is the number of moles of the compound itself. All right, number of moles of compound itself. So if the number of moles of the compound itself is 0.5, right? Now, number of moles of hydrogen atoms. Let's get now the number of moles of hydrogen atoms in this. So if the number of moles is 0.5, how many hydrogen atoms are present in the compound? So let's add. We have 3 plus 2, that's 5, plus another 3, that's 8. So 8 atoms of hydrogen are present. So 8 times the 0.5 we calculated, which is number of moles of the whole compound. So only for hydrogen now is what we are trying to get. So by the time we compute 8 times 0.5, we have 4.0 mole. So we have the number of moles of hydrogen atoms. Now we can get the number of atoms. So the number of atoms will be the number of moles, which is 4 times the Avogadro's constant, 6.02 times 10 to the power of 23. So I'll compute that here, 4 times 6.02. Okay, so I'm having 2.408 times 10 to the power of 24. So I'll just include that here, 2.408 times 10 to the power of 24. And that solves that question. All right, so you could watch it over and over again to see how it is done, get clarity. Okay, for each of the homologous series shown, name a member that contains 6 hydrogen atoms. So first, let's start with alkanes. What's the general formula of the alkane? CnH2n plus 2. So for us to have 6 hydrogens here, meaning that N needs to be 2. Yes, N needs to be 2. Okay, so because if you put 2 here, if we substitute 2 here, we're going to have 6 hydrogens. So C2H6. That's what it's going to look like. So C2H6. So what's the second member of the alkane? The second member of the alkanes is ethane. So the second member has 2 carbons, and that's how we obtain it. So go to the alkenes. General formula for alkenes is CnH2n. And we need just 6 hydrogen atoms. So to have 6 here, we just need N needs to be 3. So it becomes C3H6. All right. So the second member, the alkene with 3 carbon atoms, is propene. For alcohols, general formula is CnH2n plus 1. So for us to have plus 1 OH, sorry. Then for us to have 6 hydrogen atoms here, we need to be very careful because there is H here and there is H here. So all of them should sum up to give us 6. So that means N needs to be 2 here, because if N is 2 here, it's going to be 4 plus 1, 5 plus this 6. So N is 2. So it becomes C2H5OH. So the second member of the alcohol is the one with 2 carbon atoms, is ethanol. So ethanol. And then for the carboxylic acid, CN, general formula, CnH2n plus 1 COOH. So there is 1 hydrogen here already, and I need member 6. So it's the same thing as similar to alcohols, I think. So it's going to be 2 because you're going to have C2H5COOH. So there are 6 hydrogens present in that compound now because N is 2. So we're looking at 3 carbon atoms. So think of a carboxylic acid with 3 carbon atoms. 3 carbon atoms is propanoic. So propanoic acid. And that's how to solve that question. So you need to know the general formula to be able to derive and then the name. Unsaturated alkenes are converted into saturated alkenes by reaction with hydrogen gas. Okay? State why alkenes and alkenes are hydrocarbons. They contain, I think I did this in one of my videos on explaining introduction to organic chemistry. So they contain carbon and hydrogen atoms only. That's why they are hydrocarbons. Atoms only. The word only is very important. So please do not miss it. Okay. State why alkenes are unsaturated. Okay. They are unsaturated because they have carbon, carbon, they have carbon, carbon, double bond, carbon, carbon, double bond. Name the catalyst needed to convert alkenes into alkanes. This is simply hydrogenation. Alkanes to alkanes is hydrogenation. And it's an addition reaction, remember. So the catalyst is nickel. So nickel is the catalyst used in this process. Explain why the conversion of alkenes into alkanes is an addition reaction. I already said it. Only one product is formed. Only one product. So what makes a reaction an addition reaction is that only one product is formed. If you are not sure about this, you could watch the video on Introduction to Organic Chemistry on this channel, where I explained the reactions of alkanes and alkenes, and I also talked about all of these things there. All right, I think we're going to the last question of this paper. Okay, natural polyamides are polymers made from amino acid monomers. Name the type of polymerization reaction that occurs when natural polyamides form. Of course, you know that it's condensation polymerization, right? There's always a polymer and an elimination of a small molecule. So state the term given to natural polyamides. So natural polyamides are proteins, right? We call them proteins. An amino acid is represented, right? The amine group and the carboxylic acid group. Complete figure 6.2 to show the general structure of an amino acid. Show all of the atoms and all of the bonds in the functional group. So in this case, you have been, what has happened is that they have shown you this box, this shaded box. Okay, this shaded box represents the CH here. So remember the shaded box. The shaded box represents the number of carbon and hydrogen. So you have this middle line. This middle is representing the shaded box, right? Which I'm going to show how this is going to be formed now. All right, so that means on the left of your shaded box, you already have your nitrogen. So we're going to draw that in, okay? And then you're going to have two hydrogens attached. Then on the right-hand side of the shaded box, you have your carbon, and then you have this carbon, you have the group, right? This group. So the carbon, carboxylic acid group, rather. So we're going to have C double bond OH. All right, so the next thing you need to complete an amino acid is the fact that there needs to be an alkyl group, the hal group there, right? Needs to be present in that structure. So that completes it. So just know that the shaded box represents the middle line where you have your R coming in and then the H. All right, so we go into this question. Okay, 3 different amino acids are represented. Complete the diagram to show the part of the structure of the natural polyamide that forms when the 3 amino acids A, B, and C combine. Show all of the atoms and all of the bonds in the linkages. So we're going to see how A will first combine with B and then B combines with C. So let's start. On the left, what do we have? We start with this, okay, because this is the one that is not shaded. So this aligns with amino acid A. So the amine group loses one hydrogen. So one hydrogen is off, and then we use the continuation bond to represent it. All right, then we are moving forward. So we are going here now. Remember that in the carboxylic acid group, the OH goes off. So we're going to have a C double bond O only available there. So that C double bond O will now merge with this. In this case, one hydrogen is equally given off. So we're going to have something like this, NH. So because one hydrogen is off here, and this group is the amide link. So the amide link, and that is how we get the polyamide. So this CONH is the amide link. All right. So I'm moving forward now. We go to this part of the structure, okay, where, like I said, OH goes off again. So we're going to have just C double bond O again. One H goes off here. So we're going to have NH. And then links with this shaded one. So we're on this now. The same thing happens here. OH goes off. And then we are left with the continuation bond. So you can see that the two ends are opposite, and that's how you form polymers majorly. Okay, the two ends are opposite, two opposite functional groups to tell you that what you have done is the correct thing. And then you can see a repetition of the amide link, which makes it a polyamide. All right, you don't have to circle it. I just have to circle it to prove, to show, to buttress the point. Okay, so that's how it works. I hope it's clear. All right, next question talks about a mixture of three amino acids ABC can be separated and the amino acid identified using paper chromatography. So I have to find the RF. RF is the retardation factor or the retention factor, and is always the distance traveled by substance divided by distance traveled by solvent. So the distance traveled by solvent is always higher. Okay, always higher than that of the substance. So your RF value should be less than 1. All right, so that is for that. So retention factor or retardation factor. That's the formula. All right, so a sample of the mixture of three amino acids are placed into a baseline, okay, and is allowed to develop as shown in figure 6.5. Okay, so this is where it is placed, and you can see that the baseline is way above the solvent to allow the solvent travel up the paper, up to where the mixture is. So this is the separation of the whole experiment, and then we are told that amino acids A, B, and C are colorless. Water is used as the solvent. All right. Explain why the baseline is drawn with pencil. So we draw the baseline with pencil because the pencil is insoluble. Pencil is insoluble, or we could say that the pencil does not interact with the separation. So the pencil doesn't have any interaction with the separation. Okay, so the pencil is insoluble in the solvent. That's the type of substance used to make the colorless amino acid visible on the chromatogram. So in case, like you're already told, that the separation are not visible. So what you need is a locating agent. Locating agent makes colorless spots visible. Locating agent. Explain why in figure 6.6 only 2 spots are seen from the mixture of 3 amino acids. Since there are 3 amino acids and there are just 2 spots, it could simply mean that they have the same RF value. They have the same RF value. That is why you just have 2 spots, meaning that the other spots just fall into the same RF value. They have similar RF values. So just how the experiment can be changed to separate all the 3 amino acids. So what you can do in this case, since a locating agent will be used there, so to separate them, you could just change the solvent. So use a different solvent. Change solvent. Use a different solvent. All right. So you want to separate all the 3. Since only 2 of them were separated, so if you want to separate all of the 3, all we need to do is to change solvent. All right, and you see that the questions are quite easy. All right, so continue to watch and share with your friends so that you can also benefit. Thank you.